Hello everyone, welcome to Apex Mathematics. My name is Bino. In this video, we go through the following question which is based on number series. 3.1, we are given the geometric series which contains 3 as the first term and 6 as the second term and 12 as the third, and this series continues up until n terms. And 3.1.1, we write down the general term of this series. For a geometric pattern, we have Tn is equals to a multiplied by r raised to the power n minus 1, where the a is equals to term number 1 and term number 1 is equals to 3. It was given as 3, and r will be equals to term number 2 divided by term number 1, and term number 2 it was given as equals to 6, and term number 1 is equals to 3. So 6 divided by 3 is equals to 2. So our r is equals to 2. So we substitute. So we have Tn is equals to 3 in the place of the a multiplied by 2 in the place of the r, and this 2 will be raised to the power n minus 1, and this will be our general term for this geometric series. Question 3.1.2, we calculate the value of k such that the sum from p is equal to 1 up until to k of 3 divided by 2 multiplied by 2 raised to the power p is equal to 98,301. We have to realize that the Tn inside the summation is just the same as the general term of the series that we just determined, this one. So let's simplify this Tn. So we have Tn is equals to 3 multiplied by, suppose that we had a raised to the power b minus c is equals to a raised to the power b multiplied by a raised to the power negative c. So in the same way, we'll have 2 raised to the power n multiplied by 2 raised to the power negative 1, and our Tn will be equals to 3 multiplied by 2 raised to the power n, and we take that 2 raised to the power negative 1 from the numerator to the denominator, and the exponent will change sign to positive 1. So we can realize that what we have inside the summation is just the same as our Tn. So we can just use the a is equals to 3 and the r is equals to 2 to determine the value of k, because if we were to expand what we have inside the summation, we will get 3 as the first term and 6 and 12 as the second and third terms respectively. So we have to determine n or k. So the sum of a geometric series, we have Sn is equals to a multiplied by r raised to the power n minus 1 divided by r minus 1, and the Sn was equals to 98,301. So we have Sn is equals to 98,301. We are to determine n, and it should be obvious that n will be equals to the k that we are looking for. In the place of the Sn, we go right ahead and substitute the 98,301, and this will be equals to a, and in the place of the a we have 3. So our a is equals to 3, the first term, and our r is equals to 2, and we have to determine the n, and this will be divided by 2 minus 1. So we have 98,301, which will be equals to 3 multiplied by 2 raised to the power n minus 1. The 2 minus 1 in the denominator will be 1. We divide both sides of the equation by 3. And 3 divided by 3 will be equals to 1. So the 3's will cancel out, and we have 98,301 divided by 3, which is equals to 32,767. And this will be equals to 2 raised to the power n minus 1. We move the 1 from the right to the left, and it will change sign to positive 1, and this will be equals to 2 raised to the power n. 32,767 plus 1 will be equals to 32,768, and this will be equals to the 2 raised to the power n. So the 2 raised to the power n will be equals to 32,768. Since on the left hand side we have 2 raised to the power n, even on the right hand side we must have base 2. So why should we have base 2? Because the examiner knows that logarithmic laws are not part of your syllabus. So through trial and error, we must find an exponent which will base the 2 so that it will be equals to 32,768. So we start with 2 raised to the power 10. And 2 raised to the power 10 is equals to 1024. So let's try 2 raised to the power 11. This is equals to 2048. So we try 2 raised to the power 12. And it's equals to 4096. So let's try 2 raised to the power 13. 2 raised to the power 13 is equals to 8192. So we try 2 raised to the power 14, which will be equals to 16,384. So we try 2 raised to the power 15. 2 raised to the power 15 is indeed equals to 32,768. So our exponent through trial and error is 15. Since the bases are the same, in order for this equation to balance, our n will be equals to 15. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.